Hey everyone, this video is a continuation of probability, focusing on mutually exclusive events. So mutually exclusive goes right along with compound events. Compound probability or compound events, it's basically combining two or more things, two or more events happening. So in an earlier video, we talked about rolling a die and the likelihood of getting any one of those numbers. Now it's saying, well, what's the likelihood that you get a 1 or a 6, or just two or more events in any case? You just have to have two. You can have more than that, but it has to be at least two. So mutually exclusive events are two or more events that cannot occur at the same time. For example, you can't roll a 6 at the same time that you roll a 5. It doesn't work. You have to make sure that they don't have an overlapping area. Basically, they have no common outcomes. And what you're going to be doing here is adding the individual probabilities together to give you the total. We can think of mutually exclusive as Venn diagrams since we've already discussed those. If I let the circle on the left be A and the circle on the right be B, to find the probability of getting A or B, so this event or this one, all you have to do in this case is do the probability of A and then add the probability of B. So it's actually fairly straightforward because there's no overlapping area. You would just add them together. So if I look at my first example with this chart, find the probability that a person's favorite department store is Macy's or Nordstrom. First thing that you're going to want to make sure you do is add these together. If I were to add all of them up, that's going to give me 1, which is really good in this case because we have the full amount that we need. So find the probability that a person's favorite department store is Macy's or Nordstrom. Basically what this means is you're going to find the probability of Macy's and you're going to add to it the probability of Nordstrom. The nice thing for us is these are actually already given to us as decimals, so all we have to do here is 0.25 plus 0.20. So the probability that if I select a person at random from this survey, there is a 45% chance or 45% probability that I'm going to pick someone who selects Macy's or Nordstrom as their favorite. The second example, find the probability that a person's favorite store is not JCPenney. Key idea here is the word not. So anytime it's not, remember that's the complement. So all you're going to do is you're going to do the total 1 minus the probability of JCPenney's, or 1 minus 0.10. So we get a 90% probability. I would say that this event is very likely to occur because it's so close to 1. You have a pretty good chance that if you select someone at random, they're going to choose anything besides JCPenney's. It doesn't matter whether they've chosen Macy's, Saks, Nordstrom, or Bloomingdale's. Chances are they did not pick JCPenney's. Okay, for the next example, you see this a lot in probability. Fill in the chart for the sum when rolling 2 dice. Use the chart to find the indicated probability. So what we have here is you can think of this column here as the first die and this first row here as the second die. So this is like I roll a 1 on each of them. That's going to give me 1 plus 1 is 2. If I come down here, I rolled a 2 on the first die, but a 1 on the second die. Essentially, you're going to get the same sum if you rolled a 1 on the first die and a 2 on the second one, but we still have to list them separately. Okay, so once we have our table filled in, we can go ahead and keep moving. So first example, find the probability of rolling a sum of 4 or a sum of 5. The reason that these are mutually exclusive is because 4 and 5 are totally different numbers. So all we have to think about is we have 36 possibilities here. If you were to add up every number that you filled in, you have a total of 36, which means your denominator here is going to be 36 every single time before you reduce it. So the probability of rolling a 4, we just find however many 4s we have. And the probability of rolling a 5, we count however many 5s we have. So basically what we have here is we have a 3 out of 36 chance of rolling a 4, and we have a 4 out of 36 chance of rolling a 5. So from here, all we want to do is take our probabilities and add them together. So I had 3 out of 36 plus 4 out of 36. Both of these fractions can be reduced, but in order to add fractions, we need common denominators, so we don't want to reduce until the end. So 7 over 36, which actually, since 7 is a prime number and doesn't go into 36, we would leave it like that. For the second one, find the probability of rolling an even or an odd sum. You have two options here. So my even numbers, I have 2 plus the option of rolling 4 plus the option of rolling 6, 8, 10, or 12. With the odd numbers, you have a few less. So basically what we're going to do here is we're going to add them all up together. I have 18 even numbers. And I have 18 odd numbers. This is going to give us 36 over 36, which is a probability of 1, which makes sense because you only have two options here, even or odd numbers. And then lastly, find the probability of rolling a sum that is less than 4. Key idea here is it's strictly less than 4, which means that's only a sum of 2 or 3. Looking at our chart, that's 3 options out of 36. Or a sum that is greater than 8. Similarly, it says just greater than, so we don't include 8 as a possibility. And if we look here, that should give us 10. Adding those together, we're going to get 13 out of 36, which can't be reduced. Remember, every time you're doing probability, you want to make sure you reduce your fraction if you can. And lastly, dealing with a standard deck of cards. For those of you that don't know, a set of cards has 52. We have 4 suits: the clubs, the diamonds, the hearts, and the spades. And each suit has 13 cards in it, ace through king. Jack, queen, and king are called the face cards. 2 through 10 are called the number cards. So the probability of drawing a heart or a diamond, it's not possible to have two suits. So the probability of getting a heart is 13 out of 52. The probability of getting a diamond, there's 13 diamonds, so that's once again 13 out of 52. When we add them together, we're going to get 26 out of 52, and then we reduce 1/2. So it is just as likely to draw a heart or a diamond as it is to draw anything else, which in this case would be clubs or spades. The probability of drawing an ace or an even card. I have 4 of each card here, so I have 4 out of 52 that are aces. If you look at this first group, the clubs, I have 2, 4, 6, 8, and 10. So that's 5 even cards in this section, 5 in this one, and in this one. So that's a total of 20 out of 52. I add these together, I get 24 out of 52. Both of these numbers are divisible by 4, so that becomes 6 over 13. And then lastly, the probability of drawing a face card or a number card. Your face cards are your Jack, Queen, and King. So I have a total of 12 face cards. I have the numbers 2 through 10, so that's 9 for each of these, so that's 36 number cards, to give me a total of 48 out of 52, which once again, both are divisible by 4, simplifies down to 12 over 13.